Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today what we're going to do is an OpAmp video. I'm going to kind of give a refresher course on OpAmps. Alright, so then today what we're going to do is we're going to do another Micro-Cap tutorial. So add one to the series, alright? And this is on OpAmps. So just a little refresher here. Okay, Richard, one of our friends on the channel, asked about this, wanted to see the Micro-Cap. So I'm going to show you, there's a lot of stuff on OpAmps and Micro-Cap, a bunch. I'm going to jump into it today and we're going to go over some of it, okay? Okay, now this is two of the more common kind of configurations of an OpAmp, right? The inverting, non-inverting. You know it's inverting because the signal comes in the negative pin. Non-inverting comes in the positive pin. So whatever signal comes in the positive. This guy wants to amplify it, and it's going to keep it positive, same as it came in, non-inverting. This guy comes in negative, so he wants to amplify it, but he wants to invert it. So the gain has a minus sign, and the gain turns out to be the feedback resistor divided by the input resistor. And on the non-inverting, it's the same thing, except for because it's non-inverting, you take away the minus sign, but you also add a 1. Sometimes that 1's not very significant. If you get, say, a gain of 100 and you got a 1, it's 101. You know, it's not that significant. But a lot of times your gain might only be 3 or 4, maybe 10. So, you know, it's more significant, right? All right, I'm going to do another video if you guys want. Let me know. On OpAmps, and I can talk more about them and explain why there's a 1 and how this comes about. But for now, let's just say that this is negative feedback in both cases, right? The feedback's going to the negative pin, it's negative feedback. So in both cases, what OpAmp's trying to do is it's trying to force this pin to be the same voltage as that pin. Well, if that pin's tied to ground, then this guy wants to be 0 volts too, so he's virtually ground, he's virtually 0 volts. So, you know, often it's referred to as virtual ground. Same thing on this guy, this is virtually ground. So if you put 1 volt in here, there's no current flow. I mean, ideally there might be a little bit of leakage, but let's say you put 1 volt here, you get 1 volt here, and if you got 1 volt here, this guy wants to put 1 volt here. So if these guys are 1K, 1K, then it puts enough voltage, say it puts 2 volts out here, they get divided in half, so it puts 1 volt here. So 1K and 1K, you'd get 1 plus 1, gain of 2. So that's pretty simple, right? This goes away on this one because this guy is a voltage divider and he's kind of fighting the voltage coming in. So if you put 1 volt here and it's 0 here, you get 1 volt on this guy. Well, for this guy to force this to be 0, he's got to force the same current that wants to go this way, that way. So he has to basically apply, you know, like a negative volt. He has to cancel. So he has to put, so that you end up with 0 volts here. So the equation, you know, the amount of work to get to the equations isn't that much more. But for this video, we want to just jump into the Micro-Cap and show how to simulate these and how you can start having fun in Micro-Cap. If you haven't downloaded it, you should, right? It used to be selling for $4,700, and just over a year ago or whatever, the guy retired, decided to give it away for free. I guess he made enough money in the community and decided to help the community by giving it back. So download it and we'll go simulate. It's one of the best simulation softwares, Spice type software you can get. So you should get it. Alright, and it's fun to play with. Alright, so let's go do it. Alright guys, let's start Micro-Cap 1264-bit. Okay, it comes up, gives the tip of the day. Close that. Now what we're going to do is, you know what? It started off with the resistor. I'm just going to come to the arrow and let's start off with our OpAmp. Now we've got our 2 analog libraries here, primitives, which I can come down, primitives, and go to active devices and find OpAmp right there. And I can go to the library, or I can come down here and say find component. Let's go to library. And let's come down to OpAmps. And let's say we want to go to the audio OpAmp. And you know what? Let's go back up here. Now, if you notice in the bottom left corner, you see the symbol preview. And all of these guys have the same symbol. Whoops, except for that one. The TI has a couple extra pins. Let's go back to one of the simpler ones like this guy. We don't want to hook up too much, just an example here. Okay, now we drop it down and all right, so we got our plus pin on top with our plus supply on top. I'm used to having a negative on top, but we'll leave it that way since the plus supply is on top. So let's hook up the supply first. Let's come up here. Now I could just type in B. See, when I hover, it shows B for battery. Or I click on this and get the orientation I want. So let's just put this guy down here. I'm going to put it right down here, and I'm going to route. Okay, let's put a 15 volt, plus minus 15. Okay, let's put a 15 volt battery on it. Oh, and okay, it's showing up. It's checked, so that's good. Okay, now let's go ahead and connect that thing. I could wait and connect everything all up at the end, but I just want to show you why I put them there, because I'm going to just hook them up like this. Now he's hooked up. So then I'll run my output right out here, and I'm going to run the input. We're going to do a non-inverting, okay? So there's my plus input, and then I'll have a minus. I'm just going to, no, I'm not going to, you know what? I'm not going to do that. I'm going to go to undo right there. And I'm going to go back to my arrow, and let's grab some resistors. Now I could just type an R down here, but let's just come up here and grab this guy and put him right there at the input for the negative terminal. And I'm going to call that a 1K. Okay. And then here, you know what? What I want to show you is this thing right here, the rubber banding is turned on. See that? So I'm going to come down here and grab him and see how he stretches like a rubber band. So I'm going to put him right. I'm just going to pull him out so there's a place to connect another line right there, okay? Because I don't want the pins to pin with another pin on top of it. I like to have a little trace there that I can grab onto. Now I could go up here. I'm going to just type in R this time, okay? And it put it down the same orientation as the last one. So then I'll connect him there, and I'm going to call him a 1K. And then I'm going to come up here, hit that arrow, and I'm going to rubber band him, and I could put him, yeah, maybe I will. I'll put him right equal with that guy. And then, actually what I'm going to do is, I'm going to, see, this is a longer way to do it, to connect, move, connect. If you just place all your parts and connect them all at one time, it's faster. But I'm doing it this way just kind of show you why I'm placing things, because he's going to come around here and tie it to my return, my ground, okay? And oh, I said I was doing a non-inverting, huh? Here, let's back up, and let's bring the non-inverting, or the inverting pin to ground. The non-inverting, we're going to have our signal coming in, so I'm just going to pull him out like that. And then what else do we need to do? We need to put, you always have to have a ground symbol in, okay? You have to have it somewhere in your circuit. Now I'm not going to put it here because why? Don't want a four-way intersection. I could have put him here. This is not a bad spot because it's the input signal. It shows its reference to ground. And it doesn't really matter. It just needs to be connected anywhere along here. I'll put it on the supply side just for the heck of it. Okay. Then, okay, now I just got to come in with my input signal, which I'm going to bring it out in generator. This guy right here, the plus. Whoops. I pulled away before I clicked on it. Okay, now, alright guys, so now I'm going to connect my return, okay? So I'm going to grab a wire here, pull it down, connect it, and connect them all the returns. That okay. Now get my arrow back and double click this voltage, and I want to show this voltage the signal I'm putting in. That's this, and it shows all this stuff here. What all that stuff is all these boxes, but these boxes are associated with this pulse, this tab, and I want to choose a sine. I want a sine wave, so I'm going to choose that for my generator. And see, AC magnitude's 1, VA's 1. See all these other boxes? A lot of them are zeros. Frequency's 1 meg. That's okay. I want to do my AC analysis with 1 volt and my my voltage for my transients with 1 volt for now, just to start off with. So I'll click that and see that. Now I need to click somewhere so this is not highlighted. That way I can grab this without dragging the whole thing. I'll just place it right there. Now this right here is naming all those things that we just saw. Okay, so that's just naming all that stuff. And all right, so now the last thing I need to do is I need to give this a name. I'm going to call it V out. Now let me show you something. See that little box right there? I want to make sure that box is turned into a red dot, because if it's not, if I hover over this node, see it's just node name 3. V out's just kind of hovering up there. It's not naming this line. I want that named V out. So I bring it down here and it turns red, so it's showing a connection like these other points. Now if I hover over this, it says no name, numerically 3, but now it's also associated with the name V out. Okay, so there's my little circuit. I'm going to hit this box right here to blow it up, fill up my screen. All right, guys, that's it. So let's go simulate this thing. Let's go analysis and go transient. No, let's do the AC analysis first. Well, actually, I do want to do transient first. I just want to look at the circuit, see how it's working. Now see how it did this? So I got to hit this box again. Okay, I'm going to look at my input signal. There we go. There's 1 volt. Look, there's 1 micro. So that's a megahertz. And, you know, megahertz might be too fast for this, guys. Let's see. Let's look at the output. Okay, yeah, it's too fast for it. It's just a flat output. Something else might be wrong too. Well, first of all, I don't have a feedback resistor. We got to get that in there. So it's just open loop right now. Way too much gain. That's why it's just maxed out at my upper voltage. Look, it's maxed out at 12.9. It can't quite go to 15, but here, let's close that. Let's fix this circuit. I was going a little bit too fast there. Let's put another resistor down, call it 100K this time, or let's call it 10K. So I'm going to put it right here because I'm going to connect it to this, or down here the negative, because we need negative feedback, so it has to come back down to negative. And I'm just going to put it right up here. And we're going to make that a 10K. All right. So let's come over here and get our wires and hook it up. So hook it up to the output and bring it over here to this negative pin. See, I want to put on that wire somewhere. So right there in the middle, I think. I want to make sure I don't accidentally put this wire too close to this pin, or else it'll connect there too. So, all right. Now let's go do a transient analysis. Let's scroll this over right there. Let's look at our input again. Nice looking sine wave, 1 volt peak to peak. Let's look at the output. Man, still something wrong. It's hitting 2 volts. Now we should have a gain of 11 because we got 10 over 1 plus our 1 because we're doing we're coming to the positive terminal. So that is non-inverting amplifier, which is 1 plus feedback resistor divided by the input resistor. Something else looks wrong. I think I know what it is. Some op amps only need a single power rail, and you can tie the negative to return. I think this guy needs a negative voltage. So let's go up here and wait, hold on a sec. Let's delete this first. And see, when I hover over the scissors, if I hit Control X, it would cut it, but just cut that. And I'm going to show you, instead of pulling down another battery and all that stuff, or I could type B and a battery would pop up, I'm just going to connect that because that's the voltage I want. I'm going to say Control C, and then come over here and click, so it's going to drop, whoops. So it's going to drop it over here somewhere. And there it is. But I want to flip it like that because I want to tie this negative terminal to the negative input. This is my plus minus 15. And I'll drag it down here, and now it's connected. Everything's connected to my return. Now guys, I could have put a ground symbol on each one of these things, but that's kind of like, people have got kind of carried away with doing that. You know, used to be we connected everything together like this, so it was real obvious to the eyeball where everything is connected, and use one ground symbol. But people kind of put that as ground symbols everywhere because they're just kind of being lazy. It doesn't really look good, and on a simple circuit when you only have one return, that's fine. But on power supplies, a lot of times we have multiple returns, and then you have to decide which return each ground goes to, you know. And it's just easier when, the reason they, you know, that's a global signal, so it's globally connected to anything that looks like that, and so it's meant to make things, makes it cleaner. But when you have a whole bunch of ground symbols, that to me doesn't look clean. I mean, I think it's been abused. So we just run one line and connect it. Okay. Anyway, bigger schematics, that means more. It's just a point I'm making here. All right, guys, let's do the transient analysis again. Let's come down here to transient. I'm gonna scroll over here, and let's start off that input again. Still looking good. Let's look at our output. Now look at that. It's because this frequency is so high, and it's having a hard time handling that. And you know how we can know that? Let's go do an AC analysis. Let's come down here and go probe AC. Here, let's look at the output, and look at that. Now we started at 1 meg, and it's just dropping, so that's not helping us a lot. Let's come up here to probe limits, and let's change this. See right now? We can change this, and it tells you the format down here, what you're supposed to be in, so we could backspace over this and correct it. And here, I'm going to go ahead and do that. I'm going to show you another way to do this. We're going to end at 1 meg, okay? And then I'm going to go comma, and we're going to start at 10 hertz. There we go. Okay, now when I close this, it should rerun it automatically. There we go. So now that looks more like gain of 11. I think that should, yeah, that looks a lot better. But the point I'm making is 1 megahertz, our gain is all the way down here. So we still have some gain left, but not a lot. So what happens, we've dropped off, you know, down to, well, we're what, 17.5 dB, something like that. So we've definitely dropped off to 3 dBs, right? So when you do that, let's go back to transient. Back here, hit transient, and go look at that again. So see, the signal, the input signal is sinusoidal, but this guy, let's get it up there. But look at this. Here's a peak of the sine wave. This guy's still trying to catch up, and then it's like, whoa, hit the brakes, go the other way. And so it's running behind, and it just doesn't have the gain to keep up. And plus, look at the gain. It's not 11 volts like it should be. If we have 1 volt coming in, we should have 11 volts here, but frequency is too high. So you know what we do? Here, let's come over here, and instead of 1 meg, let's change that to 10K. And say OK. Now, our scale is only going in 1 microsecond, so again, we have to come up here to probe and go to limits again. And this time, let's see, our runtime is 1 microsecond. Let's change that to 10 milliseconds. And let's start that, well, we'll start at 0, what the heck. Okay, let's close it. Okay, there we go. That's a bunch of cycles. Okay, come up here, this scale, magnifying thing, we can zoom in. Let's just zoom in on a section of that. There we go. Now, look at this. This looks kind of clunky, right? Let's go back up to limits again. Okay, see that limits? Now, we're going maximum runtime 10, start time 10, maximum step. We just kind of let the machine kind of do what it wanted to do. Let's force that to be like, how about 100 microseconds? Every 100 microseconds we'll take a sample. Okay, let's go back to this and zoom in again. Okay, that's still not looking very good, right? So let's try that again. Let's go to probe, limits. Let's go to 10 micros. Well, you know what? We could even go 1 micro just for the heck of it. Takes a little more time, but that's still pretty darn fast. Now look how smooth and sinusoidal that looks. So we just have to get enough samples that we can, and when we hit this, I think this is right here, data point. See all those data points? If I would have clicked on that before, we would have had one here, one over here. So anyway, that's a quick way to make sure you have enough data points. Okay, that looks pretty good. And look at that. Now we got to gain 11, what we expected. And I could use these cursors if I want to drag them around and prove that to myself. It's real world, so it's, oh, look how close it is to 11. Oh, all those 9s. Okay, then I can hit my right cursor, go to the bottom, and right about there. And instead of trying to eyeball it like that, what I could do is hit this, and it finds the bottom. And if I go get my left one here and click that, it'll find the top. So there's top and bottom. Oh, there's 11 right there. Look, it's off a little bit by, look at that, 1 millivolt positive. And so there we go. Now you can start playing around and looking at things and clicking on things to see what's going on. Now see, this is reference, this signal right here. This output's come around trying to force this to be 1 volt, right? So if I come back here and I click on this, let's zoom back in on that. Now, you can't see them because they're on top of each other now. But, you can, so if I come over here and I click here, watch, this guy will disappear because, okay, so now I got the green one. It's kind of a pain to do it this way, right? Where I have to zoom in every time I change something. So there's a green one. See, there's our 1 volt. That's our feedback pin right there. So it's matching what was coming in, and that's what it's supposed to do. And because this is 10K and this is only 1K, we get a gain of 10 because of these two resistors. Because it's coming into the, this plus pin, then, we get a non-inverting signal. So whatever plus signal is here is plus out here, and that means we add a 1 to whatever that gain is. All right, so okay, so that's the transient, right? That's what we were looking at before. Okay, now if we come back here and look at the AC analysis, click on that guy, and there's our gain. And over here, this guy was here. If I click on this guy again, click on this guy first, even if I go to the other side resistor, it doesn't matter because the impedance was so high, it's the same voltage, right? But if I click here, it's gain is 0 because we got 1 volt coming in. Log of 1 is 0, and 20 times 0 is 0. So there we go, guys. And now here, another way we could have done that is come up to analysis and hit AC up here. And when you do it this way, it gives you all this. See the 10 hertz, 1 meg, and here's the number of points, 1000 plus 1, and here's the dB volts. That's why I call it V out, so that it would know that. Here's a phase. So this one was going to give us voltage and phase, and we're over here. We're choosing the log graph, and so yeah, there we go. So let's hit run. There you go. So there's the gain and there's the phase. And the reason it rolls off is because, you know, that's the op-amp's going to roll off. It's going to be gain of 0 somewhere out here, 1 or 10 meg or whatever. You know, this guy might be a 5 meg op-amp, pretty fast op-amp. But yeah, so he's rolling off because of his own internal structure. All right, guys, I think that kind of helps you get into the op-amp stuff, right? Okay, now I want to show you one more thing. Okay, let's go up here. We're going to open up another circuit. Okay, let's go help sample circuits. We love those sample circuits. Now I'm going to come down here to op amps. Now this is a schematic for classic op amps. Look at that. There's a 741. Let's click on that. Look at that, guys. That is so cool, right? I built this one time years ago because I needed an op amp, so I built it from scratch just looking at the schematic of a 741. What does this guy look like? It looks like an audio amplifier, doesn't it? Here's our differential input. Here's our, you know, see there's your plus input, your minus, and your bias setup, your output setup. Pretty cool, right? So here's why you can source and sync. And this is why you can't go to the rail on a 741, because you're going to have voltage drop on these things plus the transistors. But yeah, you can run your analysis on this stuff too. You can go, whoops, let's go up to AC analysis up here because it's all set up, I'm sure. And dB volts, phase. Okay, let's just run it. And there's the, look at that, 0 dB right here. Come out here. Crossover just past 1 megahertz, and it starts off with a gain of about 100 dB, and it starts rolling off just after 10 hertz. So there's a natural roll off, and that's the gain bandwidth at 0 dB. And look, the phase angle when it crosses over is still up here at around 95. Let's see what it is, about 97. So 180 is down here, so yeah, it's still looking pretty good as far as phase margin. So that's something I wanted to show you real quick. Oh, and by the way, come up here, hit side-by-side windows so you can see your schematic. Come over here and click on things if you want to. But okay, so one more thing I want to show you is come down here for sample circuits, okay? And come over here to op amps, and there's those things. But what I want to show you is come down here to here, let's search, okay, because I can't remember where it is. So let's just search, say OpAmp. Okay, now what I'm looking for is these types down here. See these things right here? All right, guys, so see when you click on one of these things, it shows you the example circuit right here. So I want to load that guy, and look at this one. This one simply shows you the real simple ideal model compared. You know, when you pull up here, when you click on these op amps, right here you have a level, and you can choose the Boyle level 2 or level 1. So what they've done is they've chosen ideal for this one, level 1, level 2, and level 3. Okay, now let's just do the analysis on that. And let's do the transient analysis. Let's go to transient right up here. Now look at this. Here's VN and V out 1, V out 2, and V out 3. Here's the X range and Y range. And all right, let's just run it. All right, guys, this is what I want to show you, this VN and V out. It's a pulse. And look at this. This starts at 1 microsecond and goes to 3. So that's a 2 microsecond pulse. That's like 500 kilohertz. It's pretty fast for these op amps. The ideal one, V out one, that first one, it follows inputs ideal. The second one, level 2, can't quite get there. Before it can get there, it's like, oh, now I gotta go back the other way. But level 3, the Boylston one, it has this interesting rise here, and then it tries to get there like this guy, then it kind of follows this and just gets there for a minute, just for a moment, and then has to go back the other way. So that's just showing you the different models for that particular op amp. Each op amp is going to be a little bit different, but it's showing you when you hit those different levels how real world you're going to get compared to the ideal or something in between. Okay, I just wanted to show you those things, see where to find them, and that'll give you an idea, because like on our circuit, right back here, that's something I kind of skipped over, but down here, you come in here, we're on level 3. We could have done level 1 or 2, and then over here you can even after you've selected and put it on the page, you can come over here and change your model if you want. Okay, so some things to play around with. Hope that helps. Okay guys, was that helpful? I hope that helped. I think every time you see a tutorial and I try to show some of the stuff again, so hopefully that's not too redundant, but I think I try to show different ways, and different ways to do the same thing, because there's a lot of ways to do the same thing basically in that tool. So yeah, hope it made sense and you're gonna have fun with that. Yeah, I'm set up to do another video, guys, so I thought I was gonna get this one out first, but I decided to try to help out Richard and the rest of you guys that are interested in this. So it's time to do a Micro-Cap video. This video is going to be followed up with this video. That's what kind of spun this video off. Maybe a little bit of a rant. Alright, we'll see you later, guys. See you next video. Oh, and thanks to patrons and all you guys for supporting the channel. I want to thank you guys. And a thumbs up to the video is always appreciated. Helps YouTube analytics and helps the video and all that stuff. So, alright, thanks guys. We'll see you next time.